From the fiery birth of the atomic age to the cutting-edge labs racing toward fusion, nuclear power has always walked the fine line between promise and peril. Its secrets have shaped our past and could define our future, but at what cost? The story of nuclear power begins in the early 20th century, with the discovery of radioactivity by scientists like Henri Becquerel and Marie Curie. But it wasn't until the 1930s that humanity began to unlock the immense energy hidden within the atom. In 1938, German physicists Otto Hahn and Fritz Strassmann achieved the first nuclear fission. This breakthrough ignited a scientific arms race, leading to the Manhattan Project and the creation of the first nuclear weapons. World War II marked the dark birth of nuclear power. The United States unleashed the devastating potential of the atom on Hiroshima and Nagasaki, killing tens of thousands and changing the course of history forever. What began as a quest for knowledge had become a weapon of mass destruction. This duality of nuclear energy, its potential for both creation and annihilation, would define its history. In the post-war era, the focus shifted. Governments sought to harness nuclear power for peaceful purposes. The first commercial nuclear reactor began operations in 1954 in Obninsk, Soviet Union, followed by the United States and Europe. Nuclear power promised cheap, limitless energy, but it also came with a heavy price: radioactive waste, safety concerns, and the ever-present shadow of nuclear weapons proliferation. The accidents at 3 Mile Island, Chernobyl, and Fukushima revealed the darker side of nuclear energy. These disasters exposed the risks of human error, technological failure, and natural disasters. Yet, for decades, governments and corporations often downplayed these risks, prioritizing profit and political power over public safety. While fission splits atoms to release energy, fusion seeks to combine them, the same process that powers the sun. Unlike fission, fusion promises abundant energy with minimal waste and no risk of meltdown. For decades, scientists have pursued fusion as the holy grail of clean energy. But the challenges are immense. Achieving the extreme temperatures and pressures needed for fusion is no small feat. In recent years, breakthroughs have reignited hope. Projects like ITER in France and private ventures like Helion Energy and Commonwealth Fusion Systems are inching closer to making fusion a reality. In 2022, the National Ignition Facility in the United States achieved a historic milestone: net energy gain from a fusion reaction. For the first time, we're glimpsing the possibility of a fusion-powered future. If successful, fusion could transform our world. No greenhouse gases, virtually limitless fuel, and minimal radioactive waste. It's a vision of energy abundance, without environmental destruction. But is it too good to be true? Some fear that fusion technology could be monopolized by corporations or militarized, repeating the mistakes of the nuclear fission era. Who will control fusion energy? Will it be shared as a global resource, or hoarded by the wealthy and powerful? And what about the costs? Developing fusion technology requires billions in investment, raising questions of accessibility and equity. The environmental impact of fusion is not completely negligible either. While much smaller than that of fission, questions linger about the mining and refinement of materials like lithium and tritium, which are vital for the reactors. Additionally, fusion power plants, if not well regulated, could face the challenge of producing neutron radiation, which could degrade materials over time and lead to unforeseen maintenance issues. As fusion research progresses, new breakthroughs continue to emerge. Recent innovations in magnetic confinement and laser technology have drastically improved the efficiency and feasibility of fusion reactors. Small modular reactors, some claim, could be operational within a decade. Fusion energy also opens doors to interstellar exploration. With compact, powerful energy sources, humanity could finally build spacecraft capable of reaching distant planets and even other stars. Back on Earth, fusion energy has the potential to revolutionize industries. Imagine desalinating oceans at an unprecedented scale, making fresh water abundant for drought-stricken regions. or creating carbon-neutral fuels to power sectors that are hard to electrify, such as aviation and shipping. It could also lead to advancements in quantum computing and advanced material sciences, as the byproducts of fusion experiments often push the boundaries of current technology. Despite the challenges, the race continues. Governments, scientists, and private companies are pushing boundaries. The question isn't if fusion will happen, it's when. When it does, will humanity rise to the occasion and use it wisely? Will we learn from the mistakes of our nuclear past? Or will history repeat itself? From the dark secrets of nuclear power to the dazzling promise of fusion, humanity stands at a crossroads. The choices we make today will echo for generations. What kind of future will we create? The answer lies in our hands.